Welcome everyone. Thank you for joining today's session on innovative approaches to security, microsegmentation's impact on cloud environments. My name is Venkata Nedunoori and it's a pleasure to be part of Cloud Native 2025. Over the next 40 minutes, we will explore how microsegmentation is changing the game in cloud security. By end of this talk, you will understand why traditional security models need to evolve and how microsegmentation can significantly bolster our defenses in cloud environments. Without any delay, let's proceed further. Before jumping into the actual topic of microsegmentation, let's take a step back and see cybersecurity challenges in the cloud environments. Modern cloud architectures are highly dynamic. Applications and data spread across different data centers and multiple clouds. This brings increased complexity and new vulnerabilities. Traditional security relied on a strong perimeter like a firewall at the network edge. But the cloud era, the concept of a fixed perimeter is fading away. Now, the reason because this is because attackers are continuously finding ways to pass the perimeter defenses, and once they are inside, too often they can laterally move to other systems without being detected, and that's a huge risk. So to we must evolve beyond just the perimeter defense. While firewalls and border security are still necessary, they don't they are not sufficient to protect. They are not sufficient on their own to protect the cloud environments. Think of this as securing a building. It's not enough to guard the front door, and if once inside, every room or vault is wide open. We need internal barriers as walls. This is where microsegmentation comes into picture. Microsegmentation is an innovative approach that breaks the cloud network into many small and isolated segments, each with its own security controls. So instead of assuming that everything inside our network is secured and trusted, microsegmentation enforces trust nothing and verify everything strategy internally. This aligns perfectly with the zero trust security model. Now, the objective of this session is to understand what microsegmentation is and how it differs from the traditional network segmentation, and discuss why it is crucial for cloud security and how it addresses the challenges like insider threats and lateral movement. We will also go over the components, key components, and best practices for implementing microsegmentation in cloud environments, especially with a few real world examples as well, case studies as well. And last but not the least, we will look at the future trends, including how automation and AI can enhance microsegmentation. So, overall, by the end of this session, both technical and non-technical audiences we have in today's discussion should have a clear idea of what microsegmentation's impact on cloud environment, cloud security, and get some practical insights on using it effectively. What actually is microsegmentation? So, microsegmentation is a granular security strategy that isolates workloads and applications within the network to minimize the risk of lateral movement by attackers. Now, unlike the traditional network segmentation, which divides the network into large sections using VLANs, firewalls, or subnets, microsegmentation operates at a more refined level, securing the individual workloads, containers, or even specific application processes. This ensures that even if the attacker gains access to a part of the network, they cannot easily move into other critical systems. The key principle of the microsegmentation is that to apply identity based least privilege access policies to control network traffic between the workloads instead of solely relying on the IP addresses. Instead of solely relying on the IP addresses, microsegmentation uses contextual information like application type, user identity, workload tags, and security posture, etc., to determine whether a connection should be allowed or not. This perfectly aligns with zero trust security model, which assumes that no entity inside the network should be trusted by default. Now, how does microsegmentation work? Now, how it works is basically microsegmentation works by enforcing strict access control between different segments of the network. Now, it can be implemented through host based firewalls, hypervisor based controls, cloud security groups, or software defined network solutions. These mechanisms basically allow organizations to define and enforce security policies dynamically, ensuring the workloads can only communicate with authorized services. For example, let's say a segmentation policy might permit a web server to talk to application server, but not directly a database server. This reduces the risk of data breaches drastically. Especially coming to the cloud and hybrid environments, microsegmentation is particularly useful as traditional network parameters no longer exist. Yeah, they no longer exist because cloud workloads are dynamic and static firewall rules may not be effective in controlling the traffic. Cloud native security controls like AWS security groups, Azure network security groups, NSGs, or Kubernetes network policies allow organizations to implement software defined microsegmentation, ensuring basically this ensures that the security policies follow workloads even if they move or scale up or down. Now, let's go ahead and look at a sample implementation of a micro-segmentation architecture. So, in this, if you see in this diagram, this basically demonstrates a micro-segmentation architecture where network resources are divided into isolated segments, microsegment 1 and microsegment 2. The purpose is to limit unauthorized communication and prevent lateral movement of the threads. Now, each microsegment contains three layers: web layer, application layer, and database layer, representing our traditional typical enterprise network structure. This implementation of microsegmentation ensures we can see that only authorized communication happens between the tiers, reducing the security risk. Now, the logical routers and perimeter firewalls provide high level of network security, but the real strength of microsegmentation, as you can see, comes from the next generation firewalls placed at each segment's boundary, enforcing strict security policies. With this, basically, that traffic between the microsegments is tightly controlled, meaning that even if the attacker compromises a workload in one segment, they cannot freely move to the other segment without passing through the security controls. As we discussed earlier as well, this security model aligns with the zero trust model, ensuring all traffic is verified and the security policies enforce privilege access between the different applications and components. Yeah, let's go ahead and see what are all the key differences between traditional security versus microsegmentation. Now, for decades, traditional network security models have relied heavily on perimeter-based defense, perimeter defense mechanisms such as firewalls, intrusion detection systems, and VPNs. The goal of the perimeter security is to block unauthorized access at the network boundary itself, assuming that everything inside the network is inherently trusted. While this approach worked well in static and on premise environments, today's modern cloud architecture and sophisticated cyber threats have rendered this as insufficient. The biggest limitation of perimeter security is that once the attacker gains access past the firewall, they can often move freely within the internet network. This is because traditional networks are flat, meaning the systems inside the perimeter have unrestricted communication with each other. Let's say if an attacker exploits a vulnerability in one system, they can laterally traverse to other critical systems, escalating their attack and accessing sensitive data. This type of movement, we call it as lateral movement, a key tactic used in various attacks, basically such as advanced persistent threats, APTs we call, and ransomware attacks, and insider threats. Now, as we have seen in the previous slide in the image, let's say we have a cloud hosted e-commerce application with three tiers: web tier, application tier, and database tier. With microsegmentation, attacker if a hacker exploits a vulnerability in the web server, they might be able to move laterally into the application and database tiers, gaining access to sensitive customer data without the microsegmentation. However, with microsegmentation, each tier is strictly isolated with well-defined access policies. This compromised web server cannot directly affect or connect to the database, preventing unauthorized access even if the attacker is inside the network. This segmented approach provides multiple security benefits. Few of the key benefits are prevention of lateral movement, minimized attack surface, damage and compliance, and it also helps with compliance and governance, like meeting with regulatory compliant requirements such as PCI DSS, HIPAA, and GDPR by basically ensuring that the secure workloads, sensitive workloads are isolated. Now, in the cloud and hybrid security, as microsegmentation is adaptable and to dynamic and software defined environments where workloads are more frequently move up and down, it's a key advantage of the microsegmentation. That's all. Let's move on to the next slide where we have key benefits of microsegmentation. I feel we have discussed the key benefits in the previous slide, but let's look at the key benefits briefly. The first one is granular access control. Okay. Now, we can tailor the security policies at the workload level, ensuring that only authorized users and systems can access the specific resources. With this, we are reducing the attack surface. By isolating the workloads, microsegmentation minimizes the potential targets for the attacker. And overall, we are preventing the lateral movement. Okay, so if a segment is compromised, attackers cannot easily move across other segments within the network. So these benefits make the cloud environment more resilient to the cloud threats. Now, let's see what are the key components of microsegmentation. Microsegmentation basically relies on three key components. One, policy enforcement. Number two, visibility. And number third one is the automation. These components work collaboratively and together to create a robust security framework that isolates workloads and monitors traffic and also adapts to network changes. Now, let's take a step back and look at these three components individually. The first one, policy enforcement. This uses identity based rules rather than just IP based on IP addresses. Instead of static firewall rules that rely only on IP addresses, microsegmentation basically implements the segmentation policies that may block legitimate traffic. Segmentation policies that are defined based on workload attributes, such as application identity, security tags, or user roles. Now, this ensures that the policies remain effective even as the workloads move or scale in the cloud environments. The next thing, the key component is the visibility, because without measuring the effectiveness or without measuring the internal traffic to understand the communication pattern and detect anomalies, we need that metric in order for us to implement microsegmentation. Without proper visibility, segmentation policies may block legitimate traffic as well and leave critical systems exposed. Now, in order for us to do this, we need to perform deep packet inspection, flow monitoring, and also adapt to AI driven analytics. What else I can think of? Yeah, basically these all help us identify the security risk and optimize the policies. The third one is automation. Now, as the cloud environment itself is dynamic, the policies must adapt dynamically as the workload changes. Now, this is to prevent misconfigurations and security gaps. As we all know, cloud environments are highly dynamic and workloads frequently spin up and down. Automated microsegmentation solutions continuously access the network traffic, enforce real time security controls, and minimize manual intervention. Overall, these are the key components of the microsegmentation. In the next slide, we will see what are all the different steps that we need to perform to implement microsegmentation cloud environments. Now, one thing I would like to mention is start with a phased approach. Okay. Now, we are not required to segment everything at once because it can lead to a disaster. The first step would be to map application dependencies and network flows. And the second step is to define security policies based on the actual traffic patterns. We may not be able to derive actual traffic patterns, but estimated traffic patterns to a good level of degree of accuracy should work, and deploy segmentation in monitoring mode first to detect any issues. And once we deploy the segmentation in monitoring mode and we let it run soak in there, gradually enforce the policies starting with non-critical workloads. Now, the best practice would be to involve cross-functional teams and testing policies, because common pitfalls that I have seen are like over segmentation leads to broken applications, and it's a best practice to avoid static rules and use dynamic policies that adjust with the environment. and always regularly review the policies to ensure that they still align with the business needs. Now, let's go ahead and review a couple of use cases of this micro segmentation. The first use case that I can think of is financial services. One of the industries that have benefited immensely with the micro segmentation is the financial services. This is because financial institutions handle large, high amount of sensitive data, which includes customer information and transaction records. A breach in a financial service can lead to a significant financial and reputational damage. Microsegmentation allows these institutions to separate critical data from less sensitive systems, protecting more sensitive data and most valuable information, I would say, and minimizing the potential exposure of a data breach. Similar to this, the next industry that I can see more benefited is the healthcare industry. Protection of patient data is the paramount, and health organizations must comply with strict regulatory frameworks such as HIPAA and all, in order to ensure by segmenting the cloud networks. Like this segmentation minimizes the risk of breach affecting sensitive health data for sure, but that doesn't mean that it comes without any challenges and considerations. There are definitely few challenges and considerations that we need to take into account while implementing microsegmentation, because microsegmentation is dividing your network into smaller segments. We need to carefully plan the implementation strategy to avoid any operational disruptions and ensure that the segmentation policies remain effective over time. Now, the first challenge is the complexity. Now, implementing microsegmentation requires a deep understanding of the network architecture, on how applications interact, and all. Organizations definitely must map out the communications between the workloads, identify dependencies, and define granular policies. The reason for this is because without proper planning, the risk of blocking legitimate traffic or creating security gaps that attackers can exploit is very high. The next is the performance overhead. The reason why there will be definitely performance overhead, because adding multiple layers of security can sometimes impact workload performance, especially in high traffic environments, because firewalls, security agents, and access control mechanisms require quite a bit of computational resources to inspect the and filter the traffic. Now, in order to overcome this, organizations must carefully optimize security policies and monitor system performance to balance security and efficiency without adding more latency issues. And the last but not the least is continuous monitoring. Because the cloud net, we are talking specifically about the cloud here. So, as the cloud environments are highly dynamic, with the workloads constantly changing, scaling up and down, microsegmentation policies must be regularly updated to accommodate these changes. The risk is if these policies become outdated, they can either block the essential traffic or leave security gaps that again attackers can exploit. Continuous security audits and AI driven policy automation can help policies align with evolving infrastructure. Apart from these, there are few more challenges such as operational overhead, because managing a huge number of microsegments across the cloud, on premise, or hybrid environments can significantly add administrative burden. Now, without automation, manually defining and enforcing security rules can become overwhelming as well. The organizations have to and must leverage orchestration tools and integrate segmentation with DevOps workflows to reduce this complexity. And few other challenges can be user resistance and change management, because developers and IT teams may initially resist strict segmentation policies, especially if it impacts the productivity and slows down the application development, or creates a hit on the performance. Like there could definitely be resistance, and misconfigurations is one of the key risks, because we need to make sure that the implemented automation policy validation and regular segmentation audits need to be performed effectively in order to detect and avoid any misconfigurations. These are the few challenges and considerations. Now, what are the best practices of implementing? Like the best practices, we have touched upon this in the previous slides, but let's have a quick look. The best practices are like start with the security audit. By auditing the current network to identify what vulnerabilities and understand the communication pattern between the workloads is the key thing. The next thing is zero trust. Use zero trust as foundation. The microsegmentation strategy has to be built on a zero trust model where an entity where no entity is be trusted by default, and access is granted only when properly authenticated. The third thing is automation. Usage of automation tools to dynamically adjust policies as cloud environments grow or change, ensuring the security scales with the business needs is a key best practice, I would say. And in the market right now, there are several tools available for implementing microsegmentation. A few of them are like VMware, NSX, Cisco, Tetration, or some of the leading platforms that offer comprehensive microsegmentation capabilities. And as the topic is cloud native, for cloud native environments like AWS security groups and Azure network security groups allow users to implement segmentation directly in the cloud platforms. And the last thing is the integration of microsegmentation with SDN, software defined networking, is another key trend, allowing greater agility and scalability. And basically, choosing the right tool depends upon the size, complexity, and specific needs of the cloud infrastructure. Let's look at what are all the future trends, future of cloud security with micro. What are the trends of microsegmentation in the future cloud security? Let's have a quick look. Basically, automation and AI. We are seeing rise of AI powered tools that can automatically detect threats and adjust security policies in real time. So AI driven microsegmentation solutions will enable effective predictive threat detection, allowing organizations to proactively block any suspicious activity before it escalates. And evolving threats, cyber threats, evolving threat landscape. Cyber threats have continued to grow in sophistication, which means that microsegmentation strategies, or any security strategy for the matter of fact, also must continuously evolve to stay ahead of the attackers, because attackers are increasingly leveraging AI and continuous automation to conduct lateral movement and various other kinds of attacks, because making real-time security analytics and behavior-based segmentation has become essential. Now, the future implementations of microsegmentation will need to incorporate continuous risk assessments, because that will ensure policies adapt dynamically based on new threat intelligence and attack vectors. And it's also coming up more in IoT and edge computing devices, and especially in the cloud native and multi-cloud adoption patterns. This we are seeing a lot of trend. So with this, let's look at the conclusion and key takeaways. To conclude, microsegmentation offers a significant leap towards securing a cloud environment by allowing organizations to create granular and isolated segments within the cloud environments. This does by reducing the attack surface and preventing lateral movement and providing granular control over access. Microsegmentation offers much stronger security posture. With this, thanks for the opportunity, and this is my contact information. Please feel free to drop me an email or connect with me on LinkedIn. Happy to answer any questions as well. Thank you. Have a nice day.